Welcome to the Q&A session 19 from the chapter of oscillations. The topic is the calculation of phase angle of the resultant simple harmonic motion. So this session is in continuation of the session number 18. In the session number 18, the question was almost the same, or you can say the question was the same. The only thing was that in the previous session, that in the session number 18, we have calculated the maximum acceleration of a particle which is subjected to two simple harmonic motions and as given by these two equations. So now in this session, the question is the same. It's almost the same. The only thing is that in this session, we will be finding the phase angle of the resultant simple harmonic motion. So here the question is, a particle is subjected to two simple harmonic motions as given by these two equations. X here is the displacement in centimeter and t is the time in seconds. So we have to find the phase angle of the resultant simple harmonic motion. So we will be using the formula for the phase angle of the resultant simple harmonic motion, which is given by tan, say phi r. Here phi r is what? It is the phase angle of the resultant simple harmonic motion, and this is equal to a1 sine phi 1 plus a2 sine phi 2 divided by a1 cos phi 1 plus a2 cos phi 2. So this is the formula for calculating the phase angle of the resultant simple harmonic motion. So here tan phi r, phi r is the phase angle of the resultant simple harmonic motion. So here a1 is the amplitude of the first simple harmonic motion, which is equal to root 7 into sine phi 1. Now phi 1 is the initial phase of the first simple harmonic motion. So here phi 1 is equal to 0. Phi 1 here is equal to 0 degree, and from in the second simple harmonic motion, the phi 2, that is the initial phase, is equal to pi by 3, or which is equal to 60 degree. So a1 is equal to root 7, sine phi 1 it will be equal to sine 0, which is equal to, so sine 0 is equal to 0, plus a2 is equal to 2 root 7. Here a2 is equal to, is the amplitude of the second simple harmonic motion. This is equal to 2 root 7 multiplied by sine phi 2. Now sine phi 2 will be equal to sine 60, which is equal to root 3 by 2 divided by a1 root 7. Cos phi 1 will be equal to cos 0, this is equal to 1, plus a2 is equal to 2 root 7 multiplied by cos phi 2. Now cos phi 2 will be equal to cos 60, which is equal to 1 by 2. So this is equal to, now this is equal to 0, this 2 and 2 will get cancelled out. So finally I am getting root 7 into root 3 divided by root 7, and this again will get cancelled out. So this is equal to 2 root 7. So from here root 7 and root 7 will again get cancelled out, and this is equal to tan phi r is equal to root 3 by 2. So we can say that from here that tan phi r is equal to root 3 by 2, or we can simply say that the phase angle of the resultant simple harmonic motion is equal to tan inverse root 3 by 2. So this is the answer. That is the phase angle between the phase angle of the resultant simple harmonic motion is equal to tan inverse root 3 by 2. Now if you want to calculate it in degrees, so for that we will have to refer the trigonometric table. Now in the trigonometric table you will find that if tan phi r is equal to root 3 by 2, so this is equal to 1.732 divided by 2, so this is equal to 0.866. Now in the trigonometric table you will find that if tan phi, or you can say tan theta is equal to 0.869, then theta is equal to 41 degree. So from here we can say that here the tan phi r is equal to 0.8666, and here if tan theta is equal to 0.869, then the theta is equal to 41 degree. So we can here say that phi r is approximately equal to 41 degree, because this value, that is 0.866, is almost equal to this value of 0.869. So the phase angle of the resultant simple harmonic motion will be approximately equal to 41 degree. So thank you very much for joining this session. Now in the next session, I will be coming up with a different type of a question from the topic of simple harmonic motion. So till then, have a nice day. Bye.